Hello everyone, I'm academician Dr. Lilia. Welcome to Science and Me YouTube channel. The mission of my channel is to introduce you to popular science and to create a popular science encyclopedia on YouTube. We are back with an interesting popular science video. I would be very happy if you support me by subscribing to my channel and writing a comment. If you are ready, let's start the video. Combinatorics is a branch of mathematics that focuses on counting, arranging, and analyzing objects or elements within a finite set. It plays a fundamental role in various areas of mathematics, computer science, and practical applications, including probability theory, cryptography, optimization, and more. Combinatorial techniques are essential for solving problems that involve counting, arranging, and selecting objects with specific constraints. Here are some key concepts and topics in combinatorics. Permutations. Permutations are arrangements of objects in a particular order. For a set of n distinct objects, there are n factorial ways to arrange them. The number of permutations of n distinct objects is n. For example, there are 5 equals 120 ways to arrange 5 distinct objects in a row. Combinations. A combination is a selection of objects without regard to order. The number of combinations of n objects taken k at a time is written as nck and is calculated using the following formula. nck equals n k. n k. For example, there are 10c3 equals 120 ways to choose 3 objects out of a set of 10. Combinations. Combinations are selections of objects without regard to their order. The number of ways to choose k objects from a set of n objects is represented as n choose k, often denoted as c, n, k, or simply as binomial coefficients. Binomial theorem. The binomial theorem describes the expansion of a plus b, n and is fundamental in algebra. It is also closely related to binomial coefficients. Pigeonhole principle. This principle states that if you distribute n items into m containers and n greater than m, then at least one container must contain more than one item. It is a fundamental concept in counting and is often used to prove the existence of certain patterns or properties. Combinatorial graph theory. This subfield deals with the study of graphs and networks from a combinatorial perspective. It includes topics like graph coloring, planar graphs, and graph connectivity. Counting principles. Various counting principles are used in combinatorics, such as the product rule, sum rule, and inclusion-exclusion principle, to count the number of possibilities in complex situations. Generating functions. Generating functions are used to encode sequences of numbers into algebraic expressions, making it easier to manipulate and analyze combinatorial problems. Recurrence relations. Recurrence relations describe the relationship between the terms of a sequence. They are often used to solve problems that can be broken down into smaller, similar subproblems. Probability and combinatorics. Combinatorics is closely tied to probability theory, as it is used to count the number of favorable outcomes in a sample space, which is crucial for calculating probabilities. Combinatorial optimization. This field focuses on finding the best solution from a finite set of possible solutions, often using combinatorial methods. Problems like the traveling salesman problem and the knapsack problem fall into this category. Combinatorics is a versatile and powerful tool in various scientific and practical applications, as it provides a framework for solving problems related to counting, arrangement, and selection in a systematic and efficient manner. One of the basic problems of combinatorics is to determine the number of possible configurations of a given type. For example, how many ways are there to arrange 5 distinct objects in a row? Or, how many ways are there to choose 3 objects out of a set of 10? To solve these problems, combinatorics uses a variety of counting techniques, such as generating functions. A generating function is a formal power series that can be used to represent and manipulate combinatorial sequences. Generating functions can be used to solve a variety of combinatorial problems, such as finding the number of different ways to arrange a set of objects with certain constraints. Combinatorics is a rich and powerful branch of mathematics with a wide range of applications. It is an essential tool for anyone who wants to understand how to count and arrange discrete objects. Here are some examples of combinatorial problems. How many ways are there to choose 7 cards from a standard deck of 52 cards? How many different ways are there to arrange 8 people in a circle? How many different ways are there to tile a square with 2 by 2 dominoes? How many different ways are there to paint a chessboard with 2 colors, so that no 2 adjacent squares have the same color? These are just a few examples of the many different types of problems that can be solved using combinatorics. Dear friend, I hope you benefited from the video. Thank you for watching today's video. If you enjoy content like this, please don't forget to subscribe to my channel and click on the notification bell to stay updated with new videos. Also, if you liked it, be sure to leave a like and share your thoughts in the comments. Looking forward to seeing you again with new videos. I can't wait to bring you more knowledge from the enchanting world of science.